Welcome to solverfy.
So in this question, we have to calculate the minimum pH needed to precipitate manganese 2 hydroxide so that the concentration of Mn2 plus concentration is less than 1 microgram per liter or 1 part per billion. Okay, so the reaction is we have manganese hydroxide, and that will dissociate to produce manganese 2 plus aqueous with 2 hydroxide ion aqueous. So we want the concentration of the manganese 2 plus to be less than 1 microgram per liter, and we know that the KSP for manganese hydroxide is 1.6 times 10 raised to the power minus 13. So we need to calculate the minimum pH that needs to precipitate the manganese hydroxide. So we need to find a pH so that the QSP is greater than KSP or equals to KSP. Okay, so let us calculate the concentration of manganese 2. So manganese 2 plus concentration will be equals to 1 microgram per liters divided by the molarity of divided by the molar mass of manganese, and this will be equals to 1 microgram per liter divided by, from the periodic table it says 54.94 gram per mole, and the concentration of Mn2 plus would then be equals to 1.82 times 10 to the power minus 8 mole per liter, which will be 1.82 times 10 to the power minus 8 molar. Okay. Now we can calculate the concentration of OH minus. So concentration of OH minus. So from this equation, we know we already know the concentration of manganese 2 plus, and we know that KSP will be equals to manganese 2 plus concentration multiplied by hydroxide concentration squared, and the square is coming from the fact that we have 2 at the back here. Okay, so KSP is 1.6 times 10 raised to the power minus 13. It will be equals to 1.82 times 10 raised to the power minus 8 multiplied by OH minus squared. But remember, we said we want the QSP to be greater than or equals to the KSP. Okay, so then we can say that 1.82 times 10 to the power minus 8 multiplied by OH minus square is greater than or equals to 1.6 times 10 to the power minus 13, right? So then OH minus square will be greater than or equals to the 1.6 times 10 to the power minus 13 divided by the 1.82 times 10 to the power minus 8. That will give us 0.879 times 10 to the power minus 5. Then we'll find the square root of this to get the concentration of OH minus. That will be 2.96 times 10 to the power minus 3 molar. And knowing this, we can go ahead and calculate the pOH. So subtract that from 14 to get a pH. So pOH is negative logarithm of OH minus concentration, and that will be negative logarithm of 2.96 times 10 to the power minus 3. and that will give us 2.53. So we know that pH plus pOH is equals to 14. Therefore, pH will be 14 minus pOH, and that will be minus 2.53. Therefore, pH will be equals to 11.47. So that is the pH that we need to get concentration of manganese 2 plus. There is less than 1 microgram per liter.